This video is brought to you by mywayteaching.com.
Next concept is effect of catalyst. Do you have any idea about catalyst? Why we are using catalyst during the reaction? Okay, I will explain it. Why we are using catalyst. A catalyst increases the rate of the chemical reaction by making available a new low energy pathway for the conversion of reactants to products. So catalyst, general concept of catalyst is which increases the rate of chemical reaction. Okay, which increases the rate of chemical reaction. Okay, it increases the rate of forward products. It increases the rate of forward and reverse reactions that pass through the same transition state and does not affect the equilibrium. So which increases, but it does not affect the, note down this point, it does not affect the, it does not affect the equilibrium. Okay, and catalyst lowers the activation energy for forward and reverse reactions by exactly the same amount. Catalyst does not affect the equilibrium composition of a reaction mixture. It does not appear in the balanced chemical equation or in the equilibrium constant expression. Okay, so this is about the catalyst. Next is ionic equilibrium in solution. Okay, in weak electrolytes, equilibrium is established between ions and unionized molecules. This type of equilibrium involving ions in aqueous solution is called ionic equilibrium. So please note down this. What do you mean by ionic equilibrium? Okay, in weak electrolytes, equilibrium is established between the ions and the unionized molecules. Okay, this type of equilibrium involving ions in aqueous solution is called ionic equilibrium. And next is acids, bases and salts come under the category of electrolytes and may act as either a strong or weak electrolytes. So this is about ionic equilibrium. Next is, what do you mean by acids, bases and salts? So as most of the acids taste sour, and the word acid has been derived from a Latin word acidus meaning sour. Acids are known to turn blue litmus paper into red. So acids, they convert blue litmus paper into red. Blue to red. Blue, that is litmus paper to red. Okay, and acids are to turn blue litmus paper into red and liberate a dihydrogen on reacting with some metals. Similarly, come to the bases now. Bases are known to turn red litmus to paper to blue. They convert red litmus paper to blue. Taste bitter and feel soapy. A common example of a base is washing soda used for washing purpose. Example is washing soda. When acids and bases are mixed in right proportion, they react with each other to give salts. Salts means acids plus bases. Okay, they mix with the right proportion and they react with each other, and this gives a salt. Okay, so this is about acids, bases, and salts. This is the figure. Dissolution of sodium chloride in water, Na plus, see here, Na plus and Cl minus. Ions are stabilized by their hydrogenation with polar water molecules. Okay, this is about acids, bases and salts. The next concept is Arrhenius concept of acids and bases. Now you have idea about acids and bases. And now what is the Arrhenius concept says about acids and bases? According to Arrhenius theory, okay, acids are substances that dissociates in water to give the hydrogen ions, and bases are substances that produce hydroxyl ions, that is OH minus ions. The ionization of an acid HX can be represented by the following equation. We'll write the ionization of an acid can be represented by the following equation. Hx, this can be H plus X minus aqueous. Okay, so this is the Arrhenius concept of acids and bases. Next is the Bronsted-Lowry acids and bases. According to Bronsted-Lowry theory, acid is a substance that is capable of donating a hydrogen ion H plus, and bases are the substances capable of accepting hydrogen, that is H plus ions. Okay, so this is the Bronsted-Lowry acids and bases. This is the Arrhenius concept. It is dissociating H plus and OH minus. Okay, and the next is the Bronsted-Lowry acids and bases. So what it says, and this one is the, in short, acids are proton donors and bases are proton acceptors. Okay, acids are proton donors and bases are proton acceptors. Okay, these are donors and these are the acceptors. So I will write down the, consider the example of dissolution of NH3. Example, consider dissolution of NH3 and H2O. This can be represented NH3 plus H2O, which is NH4 plus OH minus. This is base, this is acid, this adds proton. Okay, acid loses proton. This is conjugate acid, this is conjugate base. Conjugate, this is conjugate base. Okay, the basic solution is formed due to the presence of hydroxyl ions. In this reaction, water molecules acts as a proton donor and ammonia molecules acts as a proton acceptors. Okay, thus and are thus called Lowry-Bronsted acid and base respectively. Okay, in the reverse reaction, consider H plus is transferred from NH4 to OH minus. Okay, in the reverse reaction, in this case NH4 plus acts as a Bronsted acid while OH minus acts as a base. The acid base pair that differs only by one proton is called a conjugate acid pair. Therefore, OH minus is called conjugate base of an acid H2O and NH4 plus is called conjugate acid of the base NH3. If Bronsted acid is a strong acid, then its conjugate base is a weak base and vice versa. Okay, so this is about the Bronsted concept. Next problem. What will be the conjugate bases for the following Bronsted acids? HF, H2SO4 and HCO3 minus. The conjugate bases should have one proton less in each case, and therefore the corresponding conjugate bases are, so solution, the conjugate bases should have one proton less in each case, and therefore the corresponding conjugate bases are the corresponding conjugate bases are F minus, HS4 minus, CO3 2 minus. Okay, and the next problem, consider, I will write down the question. Okay, write the conjugate acids for the following Bronsted bases. Write the conjugate acids for the following Bronsted bases, that is NH2 minus, comma, NH3, comma, and minus. Okay, I will write down the solution here. The conjugate acid should have one extra proton. Conjugate acids means they should have one extra proton in each case. Therefore, the corresponding conjugate acids are, therefore, I will write down the conjugate acids here, that is NH3, NH4 plus, comma, HCOOH. These are the conjugate acids. Okay, next problem. The species, I will write down H2O, HCO3 minus, HSO4 minus, and NH3. Okay, can act both as a Bronsted acids and bases. For each case, give the corresponding conjugate acid and conjugate base. Okay, I will write down here species. This is conjugate acid, conjugate base. H2O acid. What do you mean by conjugate acid? They should have one extra proton in each case. Extra proton means H3O plus, conjugate base means less number of one proton less in each case. Next, HCO3 minus, so H2CO3. This is CO3 2 minus. Next one, HSO4 minus, this can be written as H2SO4, means one extra hydrogen you are adding. Here you are eliminating hydrogen. This is SO4 2 minus. Next, this is NH3. So here NH4 plus. Here you are removing, so that this will be NH2 minus. Okay, so this is about conjugate acids and conjugate base of this species. Okay, and next, what is Lewis acids and bases? Lewis in 1923 defined an acid as a species which accepts the electron pair and base which donates an electron pair. Here some scientists will give the idea about different concept about the acids and bases. Lewis, he explained accepts electron pair and base which donates an electron pair. This is about the Lewis acids and bases. And the next is classify the following species into Lewis acids and Lewis bases and show how these acts are such. The first one here, HO minus, second one F minus, third one H plus, this is BCl3. In that, A hydroxyl ion is a Lewis base as it can donate an electron lone pair. It is a Lewis base. It can donate a lone pair of electrons. Okay, so this is a Lewis pair. Next, fluoride ion acts as a Lewis base. It is also a Lewis base as it can donate any one of its 4 electron lone pair. It can donate any one of its 4 electron lone pairs. Okay, next, third one is C, that is H plus. A proton is a Lewis acid as it can accept lone pair of electrons from the bases like hydroxyl ion and fluoride ion. Okay, so it can accept lone pair of electrons from bases like hydroxyl ions and fluoride ions. D. Next is BCl3 acts as a Lewis acid as it can accept a lone pair of electrons from species like ammonia or amine molecules. Acts as a Lewis acid. Okay, so this is about Lewis acids and bases.